Can start. Yes? So as we learn, we have many kind of light waves that we cannot see. This room is full with Wi-Fi, full with many things, full with radio wave. So I want to check this example. So you have here a radio station, and if you know, in Israel we love to hear 107 FM, okay, radio station. And when you far away with your car, right, here's your car, you actually want to get this radio wave that's coming, right, which is electromagnetic radiation. You want to grab this and play the music, right? That's the idea. So I want to ask you, how, if this is 80 kilometers, okay, how fast this would take to the radio from here to get to there?
80 over t?
Yes, x equal vt. Waves move in the speed of light. T is the time we want to find, and x is this distance, 80 kilometers, 1, 2, 3, right? So the time, it's gonna be really short, minus 5 seconds. Really short time, okay? You can't blink in this time, okay? So this is the speed of light, okay? And I want to ask you right now, how does this thing look like? Like, what is the distance between each peak? What is this quantity is? The wavelength, exactly. So I want to know how it looks like in a more mathematical way, right? So how I can find the wavelength? What formula we know for wavelength? We know the wave formula, right? We know that v, the speed of the wave, equal to the frequency multiplied by the wavelength. We know that to be the speed of light, right? But we need a frequency. Hey, I just told you something. I told you which radio station we are listening to. So 107 actually mean 107 FM mean 107 megahertz. Everybody know that radio is a megahertz, okay? So the thing is that we know that this term is actually 107 megahertz, which is million, 10 to the 6, okay? So this is a huge number, this is a huge number, so we're gonna get kind of a nice wavelength, right? Because they're gonna kill each other. So C, if I'm gonna do wavelength equal to C divided by 107 10 to the 6, we're gonna get 10.8 meters, which mean 3 meters, okay? So when you hear radio, think about it, the electric field actually do one period in 3 meters. It's really long range waves, okay? And also the magnetic field do the same thing, okay? So that is the concept here. Cool. By the way, why when I put this in between the radio wave that we had there, in between, it stopped. Why it stopped? This is a conductor. What conductor have on it? Charge, right? Free charge, it can move. Conductor is like, everybody do whatever you like. Electrons, right? You have a bunch of cloud of free electrons. And when I come with my electric field, what this electron wants to do? They want to move in the direction of the electric field, right? Actually the opposite one, right? If this an electron, right? They're gonna, if this is, sorry, if this was a never mind. If there's if there's electromagnetic interruption, the charge would move to cancel it. So they cancel it, they stop it. And what's happened when I did that? The same thing, they stop it. But the electric field is only in some direction. Remember? X, Y, or Z. So I cancel it where it's actually changed. That's the idea, okay? So when you have food, when you use microwave, actually, what's happening? There's electromagnetic wave, and it's changing, and the plate is changing, and our food have a lot of charge, a lot of bonds of molecule water, and it's actually vibrate them, electromagnetic field. He vibrate them with this force, right? E multiplied by Q equal F. And this thing going crazy. So this thing going crazy and produce heat, right? And you just change it to play with it, okay? Good. So another question that I can ask, what is K? You know how to do it. Just take this, flip it, and multiply it by 2 pi. So K equal to 2 pi divided by lambda. And that's it for now. And what I want to say is just that next week it's gonna be our last tutorial, right? We're gonna have another extra tutorial on me, which is gonna prepare you to the exam, okay? But it's gonna be the final subject, which is gonna be the two-slit experiment. And in this experiment, people never knew if light is a wave or a particle. And this experiment actually shifts the way of the people how we think about light, but then it's become even messier, and we're going to talk about it, okay? See you next week, guys.